But let's talk about what is significant. Any number that is non-zero is significant. So if I had the number 45, both of these digits are significant, and I've got 2 sig figs. 2 sig figs there. If I have 275, I've got 3 sig figs. If I have 9,152, I've got 4 sig figs. So if it's a non-zero number, it is significant in what we're doing. If we have zeros that show up between non-zero numbers, so like 407. 407 has 2 sig figs on one on each end. And because this 0 is sandwiched in between the two, it's also significant. So if I have 407, I have 3 sig figs here. If I have 1005, I've got 4 sig figs. If the zeros show up sandwiched between 2 numbers, then they are significant. If they're not sandwiched between 2 significant figures, then they're not significant. So if they're not sandwiched between 2 numbers that are significant, they are not significant. An example of this would be something like this. 25000. This is 25,000. Non-zero and non-zero, those are 2 sig figs. These zeros are not sandwiched between any of these. So in this situation, I only have 2 sig figs. It's like saying, yeah, that car is about $25,000. It might be $25,126. It might be $24,972. But this is the amount of significance that we can claim, and the rest of it might be close, but we're guaranteeing that this is the correct part. So the zeros just give us our place value, and the 25, that is the significant number there. Same thing happens if we said 409,000, something like that. Well, 409,000, 4 and 9 are both significant because they're non-zero numbers. There is a 0 sandwiched in between them, so this whole thing is significant. I have 3 sig figs. These zeros just help get it to the right place value. Let's talk about what happens on the other side of the decimal. Let's say I have 0.0005. Just like a number that we would have as 5,000, the zeros that are after the 5 are not significant. So 5,000, it would just have 1 sig fig because these just give us place value. Same thing down here. These numbers give us place value as well. So when we're talking about a decimal, the zeros that show up between the decimal point and the first significant figure, those are not significant. So this would just be 1 sig fig that exists. If I had 0.076, this 0 would not be significant, but these 2 digits would be. So this would be 2 sig figs. The only time a 0 that's not sandwiched between 2 other numbers that remains significant is if it is at the end down here. So let's say I have this same number here, but instead it's written as 0.760. This number doesn't get written unless it is significant. So what this tells us is that the number we have is 0.0760. It's not 0.0761. It's not 0.0763. It's not 0.0759. It is 760, and then the rest that's uncertain comes down here. This is exactly a 0. So if I have that number written there, it means that I am precise up to that digit here. So I would have 3 sig figs. So for this part, I want to talk about the terminology of most significant and least significant. The most significant digit in a number gets us to the general range of magnitude that we're talking about. So in this situation, 149.05, our most significant number is in the hundreds place. It's the biggest one. It says we're about 100 here, somewhere in there. Everything then smaller than that becomes less significant to the last significant figure that we have. So this 5 is our least significant digit. It's still significant. We still can measure down to that, but it's not as significant as what we're dealing with here. Knowing the difference between these two things is helpful because of the way that we add and subtract using significant figures. All right, so on here, when we're adding and subtracting numbers of significance, let's say I take 279.145 and I add 62.11. If I do that in the calculator, I get 341.255. And the rules with the significance in the way for adding and subtracting says that the largest, least significant place drives your answer. So here's our least significant places, and 1/100th is larger than 1/1000th. So what I do here when I'm adding is I bring this down here and I put a line there. So my answer is 341.25, but with a 5 here, I still need to round up. So the answer I would have is 341.26, because this 0.5, while it's not significant overall, it's still, we have to round appropriately to bring it up there. This number goes to the hundredths. This number goes to the thousandths. So the hundredths is the largest, least significant number. So that spot drives the answer. Same thing happens over here with our subtracting. If we take this and we have our least significant number here is 3 in the tenths and then 9 in the hundredths, means this place value, we won't have anything after that. So it's 44.51. The 1 is not significant to the answer. It also is less than 5, so we don't have to round up with it. So our answer here is 44.5 when we subtract that out. Same thing happens when we come down here. It's a little bit deceiving because when we put it in a calculator, we can say, well, 86.27 plus 29 gives us 115.27. Yes, that's true. However, with our largest place of lowest significance, right here, this 9, we don't have any decimals there. It could be 29.25, it could be 28.97, we don't know. So we have to draw the line here. The decimal will not be significant in our answer. The answer we would have here is just 115. We come over here, this one can be a little bit frustrating because when you're looking at it, you don't have, you can see that you're actually subtracting something away. You have 15,000 minus 75. And when you physically take that away and you put it in your calculator, you have 14,925. But because we have this number here that's only significant to the thousands place, that means everything here is insignificant. So when we come down here, we still can only take these two digits as being significant, and with the 9 there, it rounds up. So our answer, even though we watched 75 go, our answer is 15,000. But let's say you're having a big music festival of sorts and you've got 15,000 people there. You know from the tickets you have in, you've got 15,000. Now you might have 15,020, you might have 15,192 because of different workers, of different things coming through, different whatever. And so when they ask, they say, well, what's the population? They say 15,000. And then you watch a bunch of people leave. But the estimate is still 15,000. You saw people leave. you know that you took something away. But because this part of this number isn't significant anyway, you don't know if it was 15,276 or what. So taking away that much still doesn't change the way that you would talk about it. So while it's frustrating when you put it in a calculator and say, well, 15,000 minus 75, obviously I took 75 away, so I have 14,925. But when we're talking about significance, this really could be anything in the way that would round it to 15,000. So taking away a small amount like that doesn't change the way we talk about it. The rules for multiplying and dividing can sometimes be a little more straightforward, but can still be a little bit frustrating. Because when you're multiplying and dividing, you're taking the number of significant figures that are entering into the function, and whichever number has the fewest significant figures, it's that many significant figures in the answer. So in 18 times 56, both of them have 2 sig figs, 2 sig figs, 2 sig figs. So our answer will have 2 sig figs. Well, when we calculate it in the calculator, we get 1,008. But we can only have 2 sig figs. So anything after here ends up being not significant. So the answer that I would have is 1,000. Here's the thing. I have a 0 here for my second sig fig. To identify that, I just put a line under it. That indicates that yes, this is a 0, but it's exactly a 0. It's not something that is rounding to the 1. We're rounding to this place, and when we do that, it is still a 0. So a line under it indicates that it is significant. So this has 2 sig figs. When we take this next one, it says 0.007 times 1.95. Here's where it gets a little frustrating. Because when we do this, here we just have a single significant figure. Here we've got 3 sig figs. And so we really want to be able to look at it and see it in the calculator, and it says 1.365. And we might think, well, that's a lot, so we'll just round it to 1.4 or something. But the reality is, based on our significance rules, that whatever has the lowest amount of significance heading into the function, that's the significance we end with. So we only get 1 sig fig in the end. Well, doing that, we have 1 sig fig here. And that sig fig is just our 1. So our answer here is 1. Well, that's silly. But because we don't have the significance here farther than that, it means that the rest of this doesn't get to stay. Down here, we have 6.2 times 1.7. And with this, we have 2 sig figs and 2 sig figs again. And a lot of times when you're doing stuff, you'll have similar amounts of significance in the problem that you're doing. Some of these we do really, really oddly just so we can see the difference in them. But for the most part, you'll be sticking within range. When you take these two numbers, you get 10.54, which makes some sense. You're like, yeah, I can do that. That's my calculator. I'm going to write it down 10.54. But because both of them just have 2 sig figs, that's where the answer will go. So if I take and I round this number, at this point, I'm at 11. Still a little weird. I'd be more comfortable with even like 10.5, just my own feelings, but based on the way that our significance goes, 2 sig figs times 2 sig figs, we only keep 2 sig figs, which gives us 11. With that 0.5 there, 0.5 rounds up to give that 11 instead of 10. When we come down here and we look at 345.8 divided by 91, we're taking 4 sig figs here and dividing by 2. Dividing by 2 sig figs. And that means that we'll have 2 sig figs in our answer, which in this case, it is exactly 3.8. Wahoo, yay, hooray, we get to keep it all. So 3.8, we would keep that 2 sig figs for what we have here. This last one that we have is also going to be one that has 2 sig figs. Because, again, heading in, we have 2 sig figs. Here we have 2 sig figs. That means our answer will have 2 sig figs. But in this situation, similar to what we had with 1,000 on the first one, our 60 has to have 2 sig figs. And so we have 2 ways we can do this. We can either put the underline under it, indicating that that 0 is also significant. If it is the 0 that's closest to the decimal, you could write it as 60 and put the decimal there, indicating that yes, this is still significant. There wouldn't be anything after it, but just putting the decimal there indicates that both of these numbers are significant. I don't have a preference. I think more often than not, something like this makes it more clear because the decimal can be lost, but having some way of indicating it. The other way you could indicate it is by writing it in scientific notation. You could say 6.0 times 10 to the first, because anything that's written here is significant, so it would indicate that you've got 2 sig figs here.